Machine pencil cartography. I have planned today to discuss one specific technique. This technique is called tacking. In an effort to explain what tacking is, it is essential to adequately describe the problem that tacking solves. The original navigational technique was devised by sailors who were maritime navigators who used the tacking technique to navigate in the ocean. We need to recognize that sailboats actually use the wind as their primary propulsion technique, and we should rehearse the unique ergonomics that will shape the techniques that sailors use. I will remember that when dealing with the wind, we have headwinds, crosswinds, and also tailwinds. Since sailboats use the wind as their method of propulsion, it is impossible for a sailboat to sail directly upwind, because sailing towards a headwind will cause detrainment, which is a fancy navigational term that means that your vehicle will shut off and will be unable to propel itself forwards because it will become disconnected from its source of power. In the case of sailboats, the vehicle will experience a form of detrainment that is directly associated with the orientation of the vehicle being in alignment with the orientation of the wind, and under these specific circumstances, sailors will remark that they are sailing in irons. We can infer topographically that a navigational vehicle is sailing in irons when the vehicle's heading matches the wind direction, within some amount of angular tolerance. As a result of detrainment, we can infer that when a vehicle is sailing into irons, the forces acting against the vehicle are larger than the forces acting in the vehicle's favor. We can infer that when a vehicle is sailing in irons, the vehicle will slow down to a complete stop, and if the navigator doesn't supervise their tactical situation and make an improvised course correction, then the vehicle will actually change direction and start sailing in the opposite direction, based solely on the mechanical forces involved in the free body diagram without the illusion of the navigator, which would be considered a stall. Therefore, when a person is sailing into irons, this means that they are stalling. Now that we have covered the concept of sailing in irons, this means that we are appropriately prepared to discuss the tacking technique, equipped with the understanding that sailing upwind remains possible so long as we are not sailing directly upwind, but that we are sailing upwind at an oblique angle. The tacking technique will involve sailing at as close of an angle to irons as the vehicle will allow us to sail without experiencing detrainment. This way, the vehicle is balancing its ability to navigate along the intended course against the physical requirements that will govern its navigational ability. Since the navigational intent is directly at odds with the physical geography that is responsible for producing this movement. The specific tacking technique will usually involve tacking either to the left side or the right side, since there is an orthotic stigmatism present, and the technique will involve switching sides at a regular interval so that the course made good will closely resemble the intended course. Even though the physical requirements of the tacking technique will make it impossible to travel in a tranquil course, traveling in an intrepid course fitted along the same track is considered the next best thing, and also good enough. Finally, I would like to take this time to appreciate the value of the raw material that is in front of us. It is worth noting that the tacking technique from maritime navigation will inspire navigators across the entire navigational discipline. I frequently like to cite the tacking technique as it pertains to this problem in inclined plane podiatry. What alpine navigators have discovered is that they could imitate this tacking technique that was pioneered by maritime navigators and apply this technique when they are in the mountains. In this analogy, we have replaced sailing in irons with a direct ascent where the angle of inclination was too severe to make progress up the mountain. Therefore, the irons will represent a very steep inclined plane. The technique is performed in a very similar way as it is performed in the bathymetric context, where the navigator will drive in an intrepid course so that they can ascend at an optimal rate while staying just below their maximum rate of climb. They will repeat this tacking behavior until they reach the top of the mountain. This technique is so commonplace in alpine navigation that civil engineers have learned to design roads that facilitate the application of this technique. And when they design these roads, the resulting device is commonly referred to as a switchback road. Thank you guys for listening. This has been Machine Pencil Cartography, signing out.